Hello. Um, Today, let's check out a coding assistant called Roo Code. And I actually had already done a whole recording on this, but turns out that the recording had a really bad frame rate. And so I decided not to publish that video. And I'm going to try and do it again, and it's probably not going to be as novel as the first time around I did it because I had never tried Roo Code before. But I guess also it had a lot of me like messing around and getting stuck. So maybe you might not have wanted to see that. So today we'll go over just what I had discovered about Root Code and maybe pretend that I'd never seen it before, so I could at least read along and probably go on the same adventure you guys might go on if you're getting started with Root Code as your coding assistant in Visual Studio Code. Now, if you're not familiar what a coding assistant is, it's basically kind of like Copilot in Visual Studio Code, where you chat with an AI, and then the AI will help you with your project, your problems that you're having in your code. And nowadays, it's very agentic in that these coding assistants can actually modify files on your file system or do run other tools and commands for you so that it helps you fix any coding problems that you are having. I think it's really cool. I think it's come a long way since the last time I first tried it. I was using this plugin called Continue.dev, and people have been actually hyping Roo Code over Continue.dev recently for local LLM development. And so I wanted to see how it compares with Continue.dev, and I am aware that it's like a different type of workflow, and so let's just discover that together. So today I'm on Windows. It's a sort of fresh install Windows. It was more fresh before I recorded the video the first time around, but decided not to really start over. Instead, I'll just go over briefly what we'll need. So the first thing we'll need is Elm Studio. I used to use Llama CPP and Olama and those types of inference engines, but I've just recently just started to just use Elm Studio more often because it just works. It's very reliable and it's cross-platform. Linux, Mac, Windows, it just always seems to work, and also you don't need a CUDA GPU to get this working. In fact, it runs on AMD hardware too if you use Vulkan. Okay, so it'll help you out in terms of compatibility with your hardware. Today, I actually have a GPU here, an NVIDIA GPU. So it's the same one I always use. It's the RTX A4000. I just kind of just take it out from one computer and just stick it in another. It has 16 gigabytes of GPU memory, and yeah, it's been really reliable. So I just use it. This integrated GPU here is what I use for my display, and also for recording this video. And so you'll see already a lot of CPU activity too along with it. I have about 32 gigs of RAM on this computer, but 2 gigs is already reserved for this integrated GPU here. There's an NPU. I don't know what we can do with it, but yeah, it's just there for us to use if we ever want to get into NPU development. But today we'll just be using Elm Studio. So how you get Elm Studio is you just go to Elm Studio. I think it's just search for it, and then it's lmstudio.ai, and then you can just download Elm Studio, install it, and you'll be off to races getting your first model. When it comes to the model to choose what you want for coding, okay, so we're gonna be running a LM Studio server so that Roo Code can access LM Studio's REST API, right? And the REST API is OpenAI compatible, but I'll go through that later. Basically, when you choose your model, just make sure you get one that's coder or coding specialized. I like Qwen 2.5 Coder 14B because it fits in my GPU. So I choose the 4-bit quantized version, and I increase the context length all the way up to 32K, which is the maximum for this specific model. And then I just leave everything as defaults. Just try to put everything on GPU because I can. And then I just enable flash attention to reduce the memory usage. And this is actually experimental. Not I think not every model supports it. So just be aware. But anyway, how you search for models here is if you go to this discover sidebar button here, you can start typing for some models that you want. Coder is like a good way to just kind of narrow down your search for any good coding models. So again, I like Qwen 2.5 Coder 14B. It's kind of getting old now, I think, because there's like Qwen 3, but Qwen 3 doesn't have a coder model yet. So this is still pretty good. If you don't have as good of a like GPU, unfortunately, let's say you have like an 8 gig GPU, you could always use a 7B model. Okay, so I actually just get that too, just to mess around. So this one is quantized to 4-bit. And if you're not satisfied with that, or you think you can run higher quantization, you could always choose specifically which one you want here by just choosing from the drop down. So I'll just leave this as a default. So for trying it out. There's also like from other people modifications to the models. I think some kind of try to extend the context length, and some will actually fine tune it for something else. But yeah, just choose what. Just choose anything and experiment and play with it. I mean, it's not the end of the world if it's something that you don't like. So I'm going to try. I already have the 14B installed. I also think that I should try maybe a DeepSeek one. So there's a DeepSeek coder here. So if I do DeepSeek coder, there's probably a version of DeepSeek that does coding. So this one here is from I guess 2024 on July, but this one's way too big. It's like 122 gigs. So maybe not. Maybe the best I can do here is a 6.7B model. So yeah, I think I'll just do the Qwen 2.5 7B coder, and then so this way I'll have two versions. I'll have a 14B and a 7B, and we can just kind of experiment from there. I'll get the official one from Qwen. So it's a 4 gigabyte download. So if you have a 8 gig GPU, definitely try the 7B model, quantized 4-bit. If you have a 16 gig GPU, 14B is probably where you want to be at. More parameters, the better. It'll be a better experience. I had a decent experience with the 14B model, so that's what I'll be sticking with today in this video. Okay, so let's just leave that to download. It's okay, it's going to be on the side right here. What you also want to do is make sure that you have the developer server running. So here you can just toggle this checkbox to kind of make sure that the server is on or off. It exposes an API that is like OpenAI compatible, so you'll have these endpoints here available, and these are the same type of endpoints that you would normally hit if you use the OpenAI API. We'll probably use chat completions very often, and possibly embeddings. Additionally, you want to make sure that you have the server port specified to what you want it to be. By default, it is 1234, but I've changed it to 8000. I enable cores because we're going to be writing some applications that will hit this server from the front end. and then we'll serve it on our local network. So we'll expose the server to outside of our computer. So basically, it's going to set the host to 0.0.0.0. Just-in-time model loading is fine, meaning that if we haven't loaded the model yet, and then we specify through API to do a chat completion, for example, like yeah, do a chat completion and the model isn't loaded, it'll load the model before actually running the chat completion um, for response. I leave auto unload here as unchecked, and then yeah, just keep the last JIT loaded model. Anyway, so then this server will be available from this IP import here. It'll be different for you most likely. So right now I don't have a model that's loaded, okay, but I'll just load the 14B. So here you can specify, so just go back to load the model, you just specify the options here. I max out the context length because we're coding. You're going to burn through that fairly quickly. You offload everything to GPU, and then for CPU thread pool size, we can just like max that out too. And then yeah, you want to keep all these to probably your defaults if you're having issues, but normally I try to shoot for flash attention to just reduce the VRAM usage. So if I hit load model, it'll start to load the model, and then you'll see that my GPU is starting to uh, have its memory be used. So I'm now using 15.3 out of 16 gigabytes. Okay, so next we need to get Roo Code. It's basically a Visual Studio Code plugin. So I am using my Whistle installation right now, and so if you go to extensions, just make sure you have the right extensions installed. So for me, I think it's called add installed, right? So for me, I have Jupyter installed. I also have Python, and I also have Postman installed for REST API things. So Postman's right here, so I can just like kind of make HTTP requests. I also have a SQLite viewer installed. You want this one from Florian, and then Vim extension. But yeah, so Roo Code is basically the thing that we're going to be exploring here. I don't know if I can see the page. Is there a page? Yeah. So Roo Code. So this is going to be our coding agent that's going to connect to our local model served through the LM Studio server here, and I'll just configure it with on camera too. But yeah, so what is Roo Code? So let's go to roocode.com and just check it out. Let's just read what it is. So Roo Code, it's your AI-powered dev team right in your editor. That's already exciting. Supercharge your editor with AI that understands your code base, streamlines development, and helps you write, refactor, and debug with ease. Okay, so I heard like just like spoiler alert that Roo Code seems to be more hand-holding than continue, which I think I observed the same way, but it is pretty cool. It automates a lot of your like stuff that like for example sorting imports. Um, Even though you have VS Code extensions that would do that, it's just cool to see it do it in real time. So yeah, this is just like marketing stuff. I think what we want to go see is the GitHub repo, and we can just like read this. So yeah, again, so Roo Code is an AI-powered autonomous coding agent that lives in your editor. It can communicate in natural language. It can read and write files directly in your workspace. It could run terminal commands. That's cool. It can automate browser actions and integrate with any OpenAI compatible or custom API model. So this is very important. By being able to integrate with any OpenAI compatible or custom API model, it will allow us to connect, like use Roo Code to connect to our LM Studio server so that we can stay local and use our local LLM. And that's good because you may be working on a project for work, for example, where you can't hit cloud-based LLMs, or cloud-based LLMs may be too expensive for you because yeah, it just costs to use API, or you don't want to pay for an AI coding agent. Roo Code is probably a great way to get started, along with running a local model through LM Studio if you have the right hardware for it. And even then, if you take a look at this hardware, it's not the like the highest end either. It's 16 gig GPU and 8 core CPU and about 32 gigs of RAM. So it's like an average desktop. So yeah. Um, so Roo Code can adapt its personality and capabilities through custom modes. So we'll see what custom modes is later. So whether you're seeking a flexible coding partner, a system architect, or specialized roles like a QA engineer or product manager, Roo Code can help you build software more efficiently. So Roo Code can be a coding partner, a system architect, or a QA engineer. Okay, so it has these types of roles it can take on, personalities. So what can Roo Code do? Roo Code can generate code from natural language descriptions, which is what we're going to probably attempt to do. Refactor and debug existing code, which is what we're going to do for sure. Write and update documentation, answer questions about your code base, automate repetitive tasks, and then create new files and projects. Okay, so most likely we're probably going to exercise all of these today. Anyway, multiple modes. So what is this all about? Root Code can basically take on different personalities, and these are basically the modes that they're talking about here. So Root Code adapts to your needs with specialized modes. So you have a code mode for general purpose coding tasks. You have architect mode for planning and technical leadership. You also have an ask mode for answering questions and providing information. You have debug mode for systematic problem diagnosis. You have custom modes, which creates unlimited specialized personas for security auditing, performance optimizations, documentation, or any other task. Cool. Smart tools. So Root Code comes with a set of powerful tools. So what are these tools? Let's take a look. So tools. So the tools, how tools work. So let's read that after we read this. So it can read and write files to your project. So it has these tools that can do that. Execute commands in your VS Code terminal. It can control a web browser if your model has that capability. And it can also use MCP, which is the new hotness nowadays. So MCP extends Roo Code's capabilities by allowing you to add unlimited custom tools, integrate with external APIs, connect to databases, or create specialized development tools. MCP provides the framework to expand Roo Code's functionality to meet your specific needs. Okay, so make Roo Code work your way with custom instructions, so prompts, custom modes, so you can create new personas, local models, which is what we're going to use, and then auto approval settings. So Roo Code is going to want to always ask you questions before taking actions. You can actually automate those actions, like just have it, like just do it by doing the auto approval stuff. Like you can set to automatically always just have Roo be able to read files and not ask for your permission, write files, for instance, or run like commands. Maybe not the commands part, but I mean you can, but you probably don't want that because something could go wrong. So this is if you want to run the development version. Okay, cool. So let's take a look at the tool workflow. So what can it do? Okay, so Roo Code uses tools to interact with your code and environment. These specialized helpers perform specific actions like reading files, making edits, running commands, or searching your code base. Tools provide automation for common development tasks without requiring manual execution. So the tool workflow. Describe what you want to accomplish in natural language, and Roo Code will basically be able to pick out what tool based off of your requests. Present the tool with the parameters. So before you actually let it execute, it'll tell you the command and all the arguments it wants to run with, and then it'll execute, and then just continue this over and over until it's able to finish the task. So it has all these built in already. It has a read file, search files, list code definition names, write to file, apply diff, execute a command. So that's probably just like a terminal command. Browser action, ask follow-up question, attempt completion, switch mode, new task. Cool. So this is workflow stuff. So yeah, so you'll basically have these things to auto approve. So you can select for it to auto approve anything that deals with file system reading, writing, browser use, retrying, MCP, things like that. So yeah. Yeah, so this is all like what it does. Okay, cool. So let's just move on. Okay, so now we have Roo Code. Basically, I have it already set up here. Okay, so how would you get that set up locally? Once you install Roo Code, you're going to have this thing here. What you want to do is configure your model. And basically, you're going to have a screen. You know what? Let's just do it again. Yeah, I'm just going to do it again. So let's see if I can just delete this model and then discard changes. Let's see if I could just delete this. Can I delete this? Let's see. Settings. Delete. Delete. Can I delete? No, I cannot delete. Okay, but basically what you want to do is you want to create an API, OpenAI compatible API provider. Okay, so you'll have a drop down here where you can select a bunch of providers you want OpenAI compatible, and you also want to specify your base URL. It's going to be the same URL as this one here. And then your API key, I just usually type none because it's local. You don't need an API key. And then you type the model you want. So I just copy and paste it right here. Copy and paste into Roo Code the specific model you want to use, and just keep that checked. So I think I just leave these as default, except for the context window size. I just specify that to be 32,768 because that's what it really is on mine. And then price is 0. Rest you can just leave as default. So I didn't change anything here. And then once you've configured that, you can choose your model here. By default, I just use the one that I just created, the Qwen 2.5 coder, and just test it. Just say hi. So in this case, I can change persona to be asked, so it doesn't try to do anything for me. I just type hi, and then if it works, it'll start responding in some way. In this case, I believe it's just going to yeah. So the user has sent a simple hi message. So this is actually the response from Qwen. Okay, and now it wants to basically try to do work for you. So this is what Roo has to offer. It'll ask you like, okay, so where do we go from here? What do you want to do? Do you want me to explain something technical? Do you want to have me answer some question? Do you want me to help you debug, or you want to just code with me, or do you want me to code with you? So yeah, so it seems like it's working now. Now let's actually create a project. So I actually want to do something meaningful. So I want to create a Python project. It's going to be a full stack web app that has a front end and a back end. Okay, and the plan is that we're going to have our backend interface with our OpenAI API here, right here, this compatible API, and have it do LLM type things. The app is going to be probably some sort of retrieval augmented generation application that helps us study better in terms of like reading books, and then helping feeding that book information in, having it be indexed, and then be able to search and ask questions about the book that we're reading, or a paper or technical paper. So we're going to create some sort of web app that does that. So the back end is going to be Python, and the front end is going to be JavaScript web app. So yeah, let's get started. Okay, so I have the blank folder here, made a new project just called Research Assistant. So right now there is nothing in our project. So what I would like to do is just try to get Roo started in creating a project structure. So the first thing I'm going to do is I'm going to create basic files and folders, and also a virtual environment, so that after that it can sort of just start populating the entire folder structure with the necessary files for a proper Python project. And I will handle the front end. So I'll just get started here. I use npx git ignore. to just create a gig ignore for Python, and I also do it for Node too at the top level. So so it'll actually then create a git ignore file for anything that is npm and Python at the same time. Okay, so next I will just create a readme file. So readme.md, and then I'll create two folders called backend. Okay, and then I'll create another folder called front end, and I will also create a virtual environment just at the top level directory, so that I could just like initialize it quickly. In this case, I can use, I guess I generally want to use 3.11.10 because I want usually an older version just for compatibility, but I think I can just use 3.12.3. So now I think if I were to close this and start a new shell instance, it should say virtual environment here. Okay, so I want to also install some requirements. So what we will need is, since we're making a backend application first, in Python, we'll need Flask, Flask cores, and our OpenAI library, client library, so that we can make API requests to our OpenAI server. I think that's all we will need for now. Yeah, so we could just do pip install with our virtual environment on already. Flask, I think that's how you do it. Flask cores, and also what did I say? OpenAI. So these three things here should be installed into our virtual environment, and we'll just let that go. And if we want, we can also generate requirements.txt into the backend already. But let's help out Roo a little and just create some readme.md files under these directories, so that we can sort of guide it in our prompt later. So this is going to be the Python backend service written in Flask. Okay, so this is readme.md under backend, and then readme.md in front end is going to be the front end project for research assistant. Okay, it will be a TypeScript web application initialized with Vite. Okay, I like Vite. Okay, so yeah, so we have these basic files now. Okay, so here's the task. So our task is going to be, we're going to let Roo initialize the backend as a proper Python project where we have our init py files, and have it be able to support modules so that we can import and basically develop correctly in Python, because that's usually like a pain if you're not used to it. It's hard to kind of structure your project in a way where it becomes easy to import Python modules. So we'll have it see whether or not it can do that with our local model here, Qwen 2.5 coder. And then I will just initialize the front end project. It's going to be very easy because it's going to be off from a React to TypeScript template. So let's actually prompt all that so that we can get started to do those things. I also have things that are auto approved already. I have read, browser, retry, MCP, and subtask, and maybe I shouldn't have execute, but yeah, I have all these as auto approved, so should be able to just do it on its own for at least reading files. So yeah, let's start with the prompt. Okay, so the prompt is this. I am making a full stack web application that will have a Python backend using Flask, and a front end that is going to be initialized as a Vite project with a React TypeScript template. I will first need to get started in making a project structure. I can take care. So there are two folders, right? So the two folders, backend, okay, and front end, okay, correspond to backend project files and front end project files respectively. Okay, so I will take care of initializing the front end project files. You will have to take care of initializing the backend files within backend. Okay, so what I want in this backend folder structure is a Pythonic, okay, that's like a Python project, a Pythonic project structure, okay, where I will be able to import easily my own modules that I create across other modules. Okay, so can you help me with that? Okay, as far as dependencies and virtual environment goes, I already have created a virtual environment and it is running. And don't worry about the dependencies. I have that handled. Don't create a requirements.txt. Okay, so that's going to be my prompt. So if I just send that, it's going to parse out all that and see. Let's just see whether or not it understands my request. So it is kind of a long task, but it's like a basic task. So let's see what it thinks. So I need to initialize the backend project structure within the backend directory. The user has already created a virtual environment and handled dependencies, so I don't need to create a requirements.txt file. The goal is to set up a Pythonic project structure that allows easy importation. That's a word. Importation of modules across other modules. To achieve this, I will create necessary directories for a backend project, initialize a basic Flask application, ensure the project structure supports module imports. Okay, so now I actually don't really want it to initialize the application, so I will say I don't want you to write any code yet, so let's skip the Flask application part. I will handle that. Okay, so I think I can reject that action, and then let's see what else. So it's gonna correct itself. So to create a Pythonic project structure within backend, we can follow these steps: create necessary directories for organizing the backend code, ensure the project structure supports module imports. Okay, great. So yeah, I want just for it to do this, so I can just hit approve, and let's see it get to work by watching this explorer here. So yeah, let's see. So it's actually pretty fast, right? Like, so it's a 14 billion parameter model on a GPU. Great. So let's proceed with creating the necessary directories within the backend folder. So it creates all these init pies. So config, model, services, utils. Okay, so already I'm not really a fan. So I am looking for something much simpler. Let's just create a service folder and a lib folder. Okay, so I don't want models, like config, all that things. We'll take care of that ourselves. So yeah, so let's just do a service and a lib. So let's do that. Okay, so it'll have init pi. Okay, that's fine. So we can save that. And already I don't think that's correct, right? So looking at all of this is not really correct. Okay, so let's ask, wait, first, will we be able to import modules correctly? Backend will need to have main.py as a root file. So Okay, so the root file is going to be main.py. So the trick now is, will we be able to import correctly? Okay. See, okay, so it's starting to realize that, okay, it has to actually do a few experiments to make sure it gets this right. So there you go. So now it recognized that it needs to have some sort of file here so that we can import. Okay. Okay. So now let's update the main file to import and use a new module. So yes, so it updates that, and you see how it has like two of these now. So it didn't get that right exactly, but that's okay. Okay, so yeah, it did that, but now I'm gonna ask it, can I import? Let's say I created a file in lib. Okay, oops. File in lib. Hey, how come backend lib? Okay, well, in the lib folder, can I import something from the service folder without using relative imports? Okay, so let's handle one issue at a time. Okay, so there you go. Now it found that. Okay, so now it realized it needed init.py here. Now let's see whether or not it recognized that. Okay, so backend service example service. Okay, so change that. Okay. Now, we still have this problem, right? I could just easily like remove it. Maybe I will, but let's test it. Okay, so now let's test this. So if I were to just remove this, and let's save all our files so that we can make sure that we can run main.py correctly, because we just imported some function from here, but we also want to create a lib folder that can also import something from service, but one step at a time. So backend, let's do python main.py, and already it failed. It says no module named backend. Interesting. So let's see what happens if we copied and pasted this into Roo Code. I think if I just do Control C or Shift Control C. Okay, let's see what happens. Shift Control V, Control V. I am getting this error trying to run main.py. Okay. So let's see if it recognized it. So let's see what it's trying to do. So this I do not want, right? I do not want relative imports. Okay, I also do not want sys.path. Okay, so no, reject. Okay, so I have no patience for this, right? So at this point, it has failed me on this already. So I am going to just basically delete all these things, and I'll do it myself. So, oh, jeez, reject. Yeah, no, reject. I don't want any of that. Okay. Let's see what it wants to do. If it goes in the loop, then there we go. So you're going in a loop. Let's just stop. Okay. So this was not really what I wanted. So let's actually fix this. Okay, so maybe it's my prompting skills, but this was not what I wanted. I'll delete everything here. And basically what I'm going to want is a source file, okay, or source folder. And then what we want is a main.py here. Inside the source folder is going to be an init.py. And then we're going to have two directories. We're going to have a lib directory. And then we're going to also have, what was it again? Service directory. Now within these two directories, we can have an init.py. And then we'll also have another init.py here. So here's where we can actually test. So let's have a hello.py in lib, and we can say def hello, and we just return the string hello world. Okay. In our service, we can have a service.py. So maybe we shouldn't call this lib because it's being ignored. Let's call it utils. Fine, you win. Utils. Okay, so in our service.py, let's do from. Okay, in this case, it's going to be source dot service, or not dot service, dot utils dot hello, import hello, and then we can say def print something. We can just say print hello. Okay, so that returns a string. We'll just print that. Okay, so then in our main.py, we can just do import from source dot service import what was it? Print something, and we can just specify that. Okay, so let's see if that works. Python main.py. Did we print something? Hard to tell. Oh, I didn't even save anything. Okay, let's try again. Okay, hello world. So as simple as that. That's all I wanted. That's all I wanted in a Python project, right? Like I wanted this type of structure here, right? Like a main.py at the root, like as an entry point, because that's gonna be like our Flask app, for example, or maybe service. I don't know. But anyway, so I just wanted something simple like this where now I can, like, within these folders, I can just at least absolute import whatever I need, right? So yeah, what the path I was going on, I've been through that before, where like you start to need to do relative imports or tricks where you need to do things like what was it we're trying to do earlier, where you had to, I think it was like right here, no, not there, no, basically I think, yeah, syspath. Yeah, it would have wanted to do like this thing here, syspath append, and you see this a lot in like Stack Overflow as like an answer, but really I just like this approach better. It's cleaner and it works. So let's move on. Okay, so our Flask app, I think for now let's just put it on our main.py maybe, and maybe I shouldn't have called this source. Let's clear, we should probably have called this like research assistant. Okay, yeah, let's make refactoring changes. Okay, so maybe now everything's okay. Great. So there, this is the project structure I want. Okay, so every time I want to import something, I'll do like research assistant.utils.hello, and I think it should just like work pretty nicely. So let's see. So utils service print something that imports from up here. Okay, great. So yeah. Okay, so let's make a Flask app. In main.py, let's just do from Flask, import Flask, and let's also print import JSONify, and let's also import Flask cores. Imports cores, and let's just get rid of this, and let's just create an app. Okay, that's going to be, I think, Flask, and I think the convention is just to do name like this. Cores will receive app, and we have a basic Flask app. Okay, so next, let's have our first route. So we can do app.routes. We just type hello. Methods will be get. Okay, we'll define hello, and oops, hello family friendly. Okay, so we'll define hello, and then we'll just return a 200. So JSONify, just do status okay, message hello world. Okay, and then let's return that as a 200, and then oops, let's delete this comma here. Okay, basic stuff. Now let's have a runner. So if name equals main, so if it's going to be running off as a Python script, we want to just run our app. So Flask, I think it's app.run. It's going to be host. Is we want to expose this everywhere in our local network. Port, we can just leave that as 5000, but we can change that later. And then debug is going to be true because we want hot reload. So it's as simple as just running this script, and our Flask app should be running. So this is that. So Python main.py will then allow us to yeah, have our server listen on port 5000. We can test our endpoint by making a new HTTP request with the GET request, and we do HTTP localhost 5000, which I already have, and you just send, right? And then you'll get back the JSON payload that we had specified. So yeah, appreciate the effort, Roo Code. Maybe it was just me not communicating correctly, but we'll give it another chance later. For now, let's also initialize our front end. Okay, so I'm gonna go back here, and in this case, let's go to front end, and we have a readme.md. Let's initialize a Vite project. So we go to Vite. We can initialize the Vite project here. I think it's just a command that we need to run right here. npm create Vite at latest my view app template view. Instead, we're going to change that to React TS. Okay, React-TS, which is one of the where is it right here, one of the templates we can use. So let's do that. So we're in front end folder now. Let me just kind of expand that. So we're in the front end folder now. It just has a readme.md. Just do it again in case. And then we're going to paste here React-TS, and then we're going to call this as Research Assistant. Research Assistant. Okay, this might come back to haunt me, but let's just do it. Okay, so now we have a folder called Research Assistant under our front end. We can just do npm install, and then it'll install our dependencies, and after that we'll do npm run dev, and then it'll run the dev server, and then we'll see what happens. Okay, so that's good. Install packages, npm run dev. So then we navigate to 5173 here. We have our front end running. Yay. Okay, so we have our basic project structure. So let's just commit. So git add, git commit, project structure, git push. Okay, oops, git add. Let's do it again. Git add, git commit, git push. So that should get everything. And I trust that my git ignore caught everything. I don't have any weird credentials or anything like that in the environment. So, hey, how come that didn't work? Did I not go up directory? It's weird. Okay. Okay, there we go. So now we're clean. Okay. All right. I don't even know why I called it service. But okay. So what are the next steps? Next steps. Okay. So let's create a client that will interface with our LM Studio here. So that's pretty easy. It's just using the OpenAI API. So if we take a look at OpenAI API spec, maybe it's called that. OpenAI provides basically documentation for how to use their API. Since we're using the exact client library from them, just connect it to our LM Studio server, we can just follow this documentation here pretty easily. So what we want whenever we are chatting with our LLM, we want to make a chat completions request. Okay, so to create a chat completion, it is just well, this is a curl request, but basically this is like the arguments that you would need. We can just use our library. I can show y'all that, but anyway, so this documentation also shows you what's inside the object here. Like, choices is a very popular thing because that's where your response is going to be at. And then you can also see how a chunk works. So there's two modes to doing a chat completion. There's like the regular chat completion request that isn't streaming, so you'll get the response from like the entire LLM response right away, versus streaming where it streams you like a token at a time, like a chunk of text at a time, which creates this like running effect right here. So if I said, hello, write me a 100-word story, this is like a streaming response where it shows like tokens as it come through. And that is actually a different object structure than a normal non-streaming request, in that every one of these JSON objects are returned back through like a server sent event. And within it, you have like a delta object. The delta has the content, and we'll dig through in later. But right now, let's just create the basic client and use the OpenAI client to interface with our LM Studio server. So that's our next step. Okay, so I'm just going to create another folder called client or LLM, okay, and have a init.py here. And inside this LM folder, I'll have a client.py, and this is going to be our client object that will interface with LM Studio. So all it's going to have is, so I'll design this, right? So a basic LLM client that interfaces with an open AI compatible endpoint. Okay, so what you need, how to instantiate it, is going to be base URL. Okay, so what that is going to be the base API URL ending with /v1. And then you also need API key. The API key defaults to none. And then you'll also need a model. Okay, the model to be used to chat with. Okay, so initialization arguments. Okay, and then so this is what our constructor is going to have. So then most likely we're going to store this as an instance variable, and this one too, but let's not keep this one. We'll just use this, pass it in to create our OpenAI client, and be done with it. So methods, what do we have for methods? We'll have a send message. Okay, so that's going to take in a string. Okay, so it takes in the string, and then also additional ops. So that by default that will be empty dictionary, and the options could be something like let's say you want to change the temperature and like other parameters for inference. So some of the options that you may have or may want to use to customize the responses, like temperature of the model, also sampling, right? How many tokens you want it to be considered, right? The most probable tokens right here, the top K is what LM Studio is saying. Repeat penalty, and also like min p sampling, so minimum base probability for a token to be selected for output. So it has to be at least 0.05, and then top p is cumulative probability. So usually if you do top p, temperature it becomes kind of useless. So just be aware. Normally temperature is probably what you would just want to mess around with. Okay, so that's all we're gonna have. So the first thing is we want to import our OpenAI client library. Simple as that. And then we're going to create a class called a basic LM client, or a basic chat client. How's that? Yeah. So we'll have a constructor, and then this constructor will take in, again, like I said, a base URL. Okay. It'll also take in API key, which defaults to none, and then a model. Okay. And then what we want is we want to save the base URL for whatever reason later. I don't know. Self.model is going to be there too. And then we want to initialize a client. So self.client is going to be OpenAI.client. So OpenAI client object. In this case, base URL is going to be self.base URL. API key is what it wants. It's going to be API key. And that's going to be the client. So our basic chat client also needs to have an array of messages for context, since an LLM needs to be able to read in the entire context window to generate the next token. Okay, so it's just as simple as just keeping an array of messages. That's what it is. You also need a system message, just for posterity, in terms of getting the LLM to understand its role. In this case, we can say you are a helpful research assistant. So I could do system prompt. So the current system prompt is going to be, you are a helpful research assistant. Okay. And if we have this prompt, we want to actually append that first thing into our messages array so that we can send it off with the role system, and then content is going to be self.system prompt. Okay, so that's our constructor. That's how we build up our basic chat client application. And let's see, every time we save, we should be reloading. But yeah, I haven't imported this yet. So anyway, so we have this. Okay, so now next we need a send message method. So we can define send message method. And that just takes in, so we're going to see self, string, and ops. So self message, which is going to be a string, and ops is going to be by default a dictionary. Okay, maybe I should also type these too. Okay. Okay, so how are we going to do this? So the first thing we want to do is we want to take the message that's being passed in and add that as a user message. So self.messages.append. Okay, it's going to be role user content message. So if you don't know, this is what a message looks like in OpenAI style. So in this case, if we look at chat completions here, yeah, this is what every message kind of looks like: a role and a user. I think role developer. That's interesting. I've never seen this one before, but yeah, I don't think that's very. It's per type of model. Traditionally, we can just use system. So. Okay. Actually, I'm curious. What is role? Developer message instructions regardless of messages. Okay, let's read this carefully. Developer role. The developer provided instructions that the model should follow regardless of messages sent by the user. With O1 models and newer, developer messages replace the previous system messages. Oh, this is a new thing. Okay, great. So system message, developer provided instructions that the model should follow regardless of the message sent by the user. With O1 models and newer, use developer message for this purpose instead. Okay, so we're not using O1, we're using like compatible stuff, so system is fine. Okay, so that's a structure. It's the role content. Okay, you have to specify the role, who it is. So in this case, it's user, assistant, or system, and then the content will be the content of the messages. So we want to use this now, and we want to create a chat completion. So in order to do that, I want some types to help me. So I'll import a chat completion type, so I know what I'm looking at. Actually, no, it's streaming chunk. So OpenAI import stream. Okay, so we can. So when you do a chat completion with streaming enabled, it's going to return you back a stream, and then there's also, I think, a chunk too. Let's see if we have a type of chunk. OpenAI.types.chat import chunk, chat completion chunk. Okay. So these are the types that we need to just program better. So what we want now is we're going to create a stream, okay, and we're going to use our client, and we're going to create a chat completion. So chat completion is create, and that's going to take in a model, and we just use self.model here, and then messages is going to be self.messages, so the entire messages payload. And then this is where it gets interesting. We want stream. It's going to be true, and temperature is going to draw off from our ops. So basically, we want to do ops temperature, okay? Or let's do ops.get temperature. Ops.get temperature, or basically 1.0 as like the default, okay? So yeah, so this is going to be the stream, and that's going to be a stream type. And then what we want to do is this is going to cause us to get a generator. So we want to iterate through that stream and just print it out for now. So for chunk in stream, so that's good. Each one of these is a chat completion chunk, okay? Basically, chunk now has the following structure. So I think streaming here has it. So this is one single chunk. It'll have ID, object, but then what we want is going to be choices. Choices will usually have one item, and that's going to be the delta that we want in here, and then the content we want to get here. So it's going to be chunk. Oops. It's going to be chunk dot choices 0 dot delta dot content. Okay, so delta message is going to be chunk dot choices 0 dot delta dot content. And that's the delta content. We should just say delta content. And we want to keep the assistant message building up, so we'll initialize this as an empty string. We'll print the delta content, and then we don't want new lines in between. It's going to just continuously generate, so end is nothing. And then flush is true because we want to continuously show it in our console. And as we are receiving the delta content, we want to concatenate it with our assistant message. Okay. And then finally, when we're done with this, we want to add to the messages the final message that we have built up as an assistant role. Okay. So that's the basic flow. Right now, send message is just going to print us stuff. We want to yield back eventually, but let's just do this for test right now. Okay, so now going back to our main.py, we can just import our client from research assistant .llm.client import basic chat client. we're going to create a persistent client up here. So chat client is going to be basic chat client. Our base URL we can specify to be http 192.168.1.77 port 8000/v1. I remember that. Our model is going to be, what was it again? Right here, Qwen/Qwen 2.5 coder 14b. Okay. And that's it. Our API key can stay as none. So we've created a chat client here. And then let's create an endpoint called def or app.route/chat. Okay. Methods post def chat. Now, this is going to take in the JSON payload with query as the message that the user has invoked the post request with. So we need a request object here imported from Flask, and then let's just get that data. So request.getJSON. Okay. And then let's get the query off from that data, because data is a dictionary now. So we can do get query, initialize that to none. And let's have some error checking. So if not query, meaning that if it's like an empty string, we just want to return JSONify a status. Let's just say 400. It's like status required field empty. Let's just say that message missing query field, and let's send it back as like a 400. Okay, so let's clean that up a little bit. Okay, so error checking here. Okay, next let's just run our chat completion. Okay, so client chat client dot send message is going to be the query, and we can just leave that as default, just temperature 1. Now what's going to happen is that when we receive this post request, we're just going to print it out here in our log, our terminal. We still need to return something here, so I'm just going to return basically for now like an empty JSONified object as 200. We're going to do more after this, but we want to just test to see if the streaming requests actually work. So going here in our Postman, we can create a new HTTP request. Let's create a post request here. Again, localhost 5000/chat is fine. Let's create a raw JSON payload. So query, let's do, hi, I need some help with Python. Okay, that's going to be our message that we send. So if we send, you see text is starting to stream, and again, error. We'll figure it out. Okay, so quickly, you saw that it says, of course, I'd be happy to help you with Python. What specific issue or question do you have? Are you working on a particular project, or is there a concept in Python that's confusing? Let me know how I can assist you. Okay, so it works. It does stream, but I don't know what the heck just happened here. Let's just see. What is the exception? Okay, so let's see what's wrong here. So it all starts down where? Here? So can only concatenate string, not none type to string. Oh, okay. So eventually these chunks stop, I guess, sending content. So we need to actually check for that in our client here. In this case, delta content can be none. So maybe we can start with, if delta content is none, we can just break. Okay. Now let's try that again. Let's just invoke our post request. So of course, I'd be happy to help with Python. What specific issue or topic do you need assistance with? Please provide some details so I can better understand your needs and offer the appropriate guidance. Okay, so that's great. So it works now, but we need to actually send back some payload so that we can, potentially render all this from the front end. Because right now it's just printing to the terminal whenever we make a request. So what we want to do is, since this is streaming, we want to treat this as a generator. So in this case here, we, instead of printing this, let's actually return back the delta content. So we can just yield, in this case, yield delta content. Okay, so if we yield delta content, basically what we need to do is in our Flask API, instead of just calling it this way, we can create a generator, like a generate function, for example, like def generate, and iterate through this call here and create a little JSON chunk that we can just send back to the client using some Flask related things. In this case here, let's start. I think this is something we can actually ask the LLM on how to do. I kind of have an idea already, but let's just do for chunk in chat client send message, for example. Okay, so we're going to have a chunk. What do we do with it, right? So we'll need to yield, okay, JSON dot. In this case, we want to send this as like a JSON string, okay. So we're gonna import JSON, for example. You're up here maybe. Okay, so JSON dot loads. It's going to be a chunk, and it's going to be the chunk data, and then we're going to append a new line every single time. Okay, loads or dumps. Sorry, dumps. Dump this object as a JSON string. Okay, so what this generate function is going to do is, well, it's going to call chat client send message with our provided query, and that is going to yield delta content every single time it gets a chunk from the stream. Once it does that, this chunk object is obtained, and we can actually construct a JSON string in this format. It's arbitrary. I decided to just make it like this JSON object the way it is. No real reason. I just do JSON.dump s to create a string representation and add a new line at the end, so that on the client side, we would know that we're receiving one of these objects at a time in the stream. And so at the end of it all, when this is done streaming, this should also be done streaming too. But we need to be able to return a Flask response and stream these chunks as they come through to the client. And how you do that is actually not just a simple JSONify. We need to actually write some extra code to get this done. So let's ask the LLM for help. So I think if I just do Control-Shift-L, would that actually add it to Roo Code? Let's see. Selection, add to Roo Code. Okay, so I have this generate function here. My intention is to stream these chunks being yielded from my client.py back to the front end in a SSE server sent event fashion. What else do I need to do here in Flask so that I can return the response as appropriate? Okay, so what is it going to do? So given this generate function, we want to be able to have Flask invoke this generate so that it can continuously send back these JSON string representations of the chunk that is being received from the OpenAI compatible endpoint. So good question for it to ask, for us to ask the LLM. So to stream the chunks yielded from your generate function back to the front end in server sent events fashion using Flask, you need to make a few changes to your Flask app. I already have this installed. Okay, you need to install Flask, which I already have. You want to create the Flask. Okay, I already have that. Define as okay, I already have that. Okay, so no, reject. Okay, create the Flask app. Okay, I already have that done. So it has. Okay, it does all this stuff here. So maybe I'm not doing this right. I don't know. So let's see, update main py to run the Flask app. I already did. Okay, so let's nudge it. I already have. Oh, create the Flask app. I already have this Flask app implemented. I just need you to help me with the return part. So okay. So what do we have here? So we need to import response. Okay, so I don't know. Let's see first. Let's see kind of complete itself. Let's make this bigger. Okay, so this is what we need. So here is we need to sorry. Jesus. We don't need to do it this way for now. Okay, event source. Okay, what if I don't want to use event source? Can I just stream JSON back? I guess because server sent events have to have like a specific structure and things. So so I think I get the point. I think what we want to do is just return this response generate. But in Flask, there's also something called a streaming with contexts Flask. So that streaming contents right here. This is, I think, an easier way to do things. I think streaming with context. Yeah. So here, streaming with context. See, good old Google still works. Okay, the request will not be active while the generator is running because the view has already returned at that point. If you try to access request, you'll get a runtime error. So if your generator functions relies on data in request, which we do, right? Use the stream with context wrapper. This will keep the request context active during the generators, because what's going to happen is that if we don't use it, this stuff here is going to go away, right? So basically, here's our generator here, and we just need to do stream with context generates. Yeah. And this will actually just create a response object automatically, but let's just do it properly by importing the request object. So if we import a response object, and then we also want to do stream with context. So we can do response right here, and then we can specify stream with context with the generate function being called. Okay, so that's like the first thing that we can do. So, and then we also want the MIME type, in this case, to be, I think, application JSON. Okay, we're gonna assume this is JSON. Okay, so we also want to return 200. Okay, so this is really the right way to do this. This is, I don't know what this is. Let's just cancel it and terminate. I don't know what this is. Okay, so far, not very helpful. I'm gonna just keep my mind open. Okay, so maybe I'm doing everything wrong. I don't know. So let's just do this now. Let's test it now. So what we've done is we've we've created a generator that will yield back chunks, and then we're gonna have Flask stream that all back with this line here, return response stream with context, calling the generate, and then yeah, regular 200. So if we were to test this again, we're gonna get back JSON. Now, one thing I want to note is that I think in Postman, you're not going to get that streaming like effect. We're just gonna end up seeing everything in one go. Maybe we can change it somehow. I don't know how to do that here, but yeah. So if we see a bunch of JSON lines, that means everything is working. Let's just say that. But I would like to see if we can set something that allows us to stream. So let's see here. No. Let's do post. Let's just do, oh, it's not hello. Let's do chat. Okay. Raw. In this case, we want JSON, and it was query is what we wanted. Hi, I need some help with Python. How do I create a virtual environment? Let's say that. Okay. So this is going to trigger a bunch of JSON lines to show up, ideally. Let's invoke that. And it should take a while because it's going to do everything in one go, but we can monitor our LM Studio, and it did see that it is generating the first token. So it's doing something for sure. It's probably something very long. I think we should also set our logging to be verbose. Let's see what happens, and then we can log incoming tokens too. Not sure if we have to reset the server, but it is generating. Okay, so it's ready, means that it's done. Okay, so here we go. So here are all the chunks that were received. Okay, so in this case, we can just do raw. Okay, so we have creating a virtual environment in Python is a great way to manage dependencies and isolate your project requirements from other projects or the global Python installation. Here's how you can create a virtual environment using venv, which is included by the, okay, so it does, these are all the chunks that are received. So we can actually write like a front end application that will be able to take these chunks and display it in like a div or a text box or something like that. But I do notice that it is hard to understand when this thing ends. So let's add another chunk that will just have 2 new lines, okay, at the very end in our generator here. So somewhere here. Okay, so at the end of the loop, we should just yield JSON dumps again chunk, and then we're gonna have 2 new lines plus a new line here. Okay. So if we do that again, let's just make it simple. Let's just go hi. Okay. We'll send, and then we should get back, hello, how can I assist you today? New line, new line. So at least we'll be able to tell when our response ends from the front end this way. So we have a basic API going. Cool. Okay. I'm going to commit this. Okay. And what I'm going to do is I'm going to give the LLM one last shot. Okay. I'm going to have it organize all my imports. Okay. And also have it get rid of unused imports. So let's do it. Okay. And let's watch our project structure. Okay. So let's prompt. I have a project, my Python project is under, in this case, backend. Where's my backend folder? Okay. I would like you to go through all my .py files and sort, organize, group, and remove all my, or remove, group all my imports, and then after that remove all unnecessary or unused imports. Okay, So it's a simple task. I think you could actually just do it with like a plugin or like a command line, but it at least should know how to do this. Okay, so it's not like this sucks or anything like that. I think it's just more like I think the model is just not smart enough. It's kind of like lobotomized because it's been quantized. So maybe next time let's try like a higher quality model but with less parameters. Or maybe like something with more parameters and more quantized. Let's see. But so it's reading all the files and it does see like some of my imports and let's see what it wants to do. So Roo wants to edit this file. Okay, so it already did that, so it organized. Okay, sure. Save. It did that. Okay. Okay, so it's gonna see if. Whoa, shoot. Did I just let it run sudo apt install flake 8? Wow, okay. Should I? Okay, well, surprised. Okay, so password. I guess I still have to be attentive anyway. Okay, so let's see. Internet's a little slow. Do you want to continue? Yes. Okay, so at least it read that the command is done, and we can execute again to remove any unused imports. Okay, so interesting that it's only doing one file at a time, and it also even has unrecognized. It's passing in unrecognized arguments. Do you have AutoPep 8? I don't know. How do I know that? I don't know. No, I don't. What are you gonna do? Yeah, just manually do it. Okay, so all imports are used in code. Is it now? Okay, great. Okay. Well, you only did one file. What about the rest of my .py files in my projects? I thought we were looking at backend. Come on, finish the job. Okay. So I think the first time it didn't recursively do it, maybe. Let's see, let's look at the history. How did it come to be? Oh yeah, it just never, it just didn't recursively look. Okay, so now it's found it all recursively. So maybe it'll do better this time. Hello. Is it just. Oh, it's generating. Oh, I see what it's doing. It's generating all this in the background. Okay. So now client. Okay, so for sure client has one. I know it's this one. It's just chat completion chunk one. It has to find that one. It has to. And yes, maybe like I could have just done all this by myself because it's a small project so far, but I'm thinking like in scale, I think this would be helpful maybe. If it's gonna do it all correct. Let's see. So I think it's still trying to figure out like what's it's doing. So it's generating like a patch, it looks like. So oh, this one's still going. Okay. Okay, so it found that. So did it find chat completion chunk? Well, it ended up fixing my spacing, but did it ever? What did it do? Okay. It didn't look like it. I don't know. It's still. You know what's even crazier is that now it's duplicated. And it did that thing again. Like, that's what I saw last time. So far, not good. Yeah, I think I'm just gonna. Oh, okay. You know what? This is fine. This is okay. It's okay. It's okay. Yeah. No. No. Just delete that. First, JSON isn't even needed. I think. Let's see. Oops. JSON isn't even needed. I'm pretty sure. Yeah. So that's silly. Silly. It did that. Okay. Okay. It did get rid of one space for me, but not really what I wanted. I'm even like now doubting this. Like, is it all correct? Let's see. Yeah, it still works. So, okay. Well, we tried. We tried making it work. I'm just gonna commit this again and just say some cleanup. Alrighty. Well, maybe next time it'll be better. I don't know. Maybe not good as a coding assistant, but actually let's try a bigger model next time. Yeah. This is yeah. Anyway, that's good enough for today. Thanks.